Good everyone, my name is Graphics. Today we want to study an aspect of technical drawing which is under geometric construction. And what we're talking about will be polygons. We know that polygons is a plane figure that is bounded by 3 or more lines. Now, when the lines are equal both in angles and in length, you term that kind of polygon a regular polygon. Example, your square, your triangle, your pentagon, your heptagon, right? As long as all the lines that makes up this polygon is the same, is of equal length, equidistant to each other, and the angle are also the same. Like for example, let's take this. If I am to draw an equilateral triangle, we know that in an equilateral triangle, all the sides and the angle are the same. So let's assume that the length of the equilateral triangle is 60. So I'll be starting from 30, right? And I'll be ending at 6. So from 30 to 6 is 60, right? And I'll term that point A, and what? Point B. Now, if I take my compass and I place it at the two ends here, right? I come up to this point, I bisect an arc. I come up to this point also, I bisect another arc. Now, if I join the three lines, together from here to this point, right? I will have this. I'm going to have this. And if I join from here to this point, I will have this. Now, if you look at this, you discover that this is A, B, and what? And C. If I measure from A to B, I'll be having 60. You can see from 0 to 6. Right? Now, if I measure from A to C, I also have what? 60. You can see, starting from A to C, I'm having what? 60. Similarly, if I do from C to B, I also have what? 60. Now, such a triangle is said to be what? Equilateral, and it is a regular polygon. Even if you go as far as measuring the angle, you discover that what? The angle involved is what? Angle 60 degree. So it means that from this point to this point, or from this point to this point, or from this point to this point, they are all what? At angle what? 60 degree. All the angles are the same. So this is 60 degree. This is another 60 degree. This is another what? 60 degree. Is that taken? And the size is 60 millimeter also. So there are other kind of polygon too, just like the triangle, equilateral triangle. We have the square. Now if you look at the square now, let's see that of square. So on the square, I'll take my AB to be 50. Let me just assume that the AB is 50. It can be more than that or it can be less than that, depending on what you want to choose, right? So let me take the AB to be what? To be 50. Now, if I draw a perpendicular line here, I can just decide to just take my set square to make my work faster, and I'll just draw a vertical line faint. I'll come here also, I'll draw another vertical line faint also, right? So if I just take it from B to A here with my compass. I'm going to just bisect up, and I'll come here also, I'll bisect up. So where they meet, I'm going to what? I'm going to thicken them. So from A, it ranges up to this point, and from B, it ranges up to this point. So this is what we are having here. So this is A, B, C, and what? D. Now in this square, all the sides and angle are what? Are equal, because we know that from A to B is 50, from B to C is also 50, just like what I'm showing here now. So from here to here, you can see from 0 to this point, from C to A is 50. Also from D to B is also what? Is also 50, right? You can see that. Also from A to B is 50. From A to B is 50. You can see that. And also from C to D is what? 50. So all the sides are equal. So you can call this a regular polygon. There are many examples you can use. You can watch some of my videos talking about polygons. You see we have the pentagon is an example of a regular polygon. Hexagon is an example of it also. Regular, you call it regular hexagon, regular pentagon, regular octagon, regular nonagon, and that is how it goes. Now let's see that for what? For an irregular polygon. Now an irregular polygon is a polygon. No, I defined polygon earlier, irregular polygon, as a plane figure that is bounded by what? 3 or more equal lines. All the lines are the same, have the same length, right? But in irregular polygon, they don't have the same length. Their length varies. AB is not equal to BC, is not equal to CD, is not equal to, and so on and so forth, right? So let's take for instance now your rectangle. Let's try that of rectangle. So if I'm drawing rectangle, we know very well that if I should draw a line this way, and I decide to say this point here is A, and let me assume that the length of my rectangle is 60. Is that taken? Is 60 AB. The length of my rectangle is what? Is 60. So if I should do that, and I draw a vertical line this way, and I assume that the height of my rectangle is 40. It's 40. So from 1 to what? To this. So let me just take in that. And let me complete that from here. Now this is a good example of an irregular what? Irregular polygon, because all the sides are not equal, right? AB is not equal to what? BC. Start taking now. So you call the rectangle an irregular polygon. Example of another one here we have again is a scalene triangle. You know, earlier we talked about an equilateral triangle, right? We talked about an equilateral triangle. Now we want to talk about a scalene triangle. So in the scalene triangle, we know all the sides are not equal, right? And the angles also what? Are not equal. So if I should draw my scalene triangle, let me assume that I'm moving from 40 to 44 or to 50. I just take the height. Let me say AB, this is AB. AB is 40, right? Let's confirm that. AB is 40, is 50, right? Then I might now say that my AC should be like 70. AC should be like 70 or 60 if I'm not mistaken, or 70, let's use 70. If I place it at the AC here, I'll just strike and add this way. This is my AC. And I can see that if my AC is 70, I can say my BC is maybe 20 or 50. That again, if I place it here, I can easily just strike an arc. So where they meet, from here to here, will be this, and from here to here is this. So this is my point C. So this is not a regular polygon. It's an irregular polygon because all the sides and the angle are not the same. So a good example of an irregular polygon is a scalene triangle. You can even call an isosceles triangle also. Is that okay? So, and more example of an irregular polygon are irregular heptagon, irregular nonagon, irregular hexagon. So when you are calling it, when you say irregular, no, regular pentagon now is a polygon with 5 equal sides. But irregular pentagon now is a polygon with 5 non-equal sides. Is that okay? So if this video will be helpful, please don't forget to click on the subscribe button. Thanks for watching.